Good day, students. This is Math 1026 Video Solutions, and this is for pages 15-16 in Book 2 of Math 1026 booklets. And this talks about simplifying rational expressions. And you see I picked numbers 2, 6, 7, and 14 from those two pages. So let's have a look at simplifying rational expressions. If you look at the first one there, number 2, you can see the expression negative 15x squared y z to the 4 all over 27x squared y cubed z squared. Now, these are all multiplied, right? In between this that means times, right? This is all multiply in between. So, because of that, everything is multiplied. We can actually reduce this without any further work. We can look at each part separately. For example, just reduce the fraction negative 15 over 17, right? So all we need to do is reduce that. So if I reduce negative 15 over 27, then all I need to do is divide each side by 3. That would give me negative 15 divided by 3 is negative 5. 27 divided by 3 is 9. So I just reduce the fraction, or the numbers, the coefficients in front separately. Now, and again, because it's all multiplied, I can look at each individual group or letter or variable separately, right? So if we look at x squared over x squared next, we can see that if we subtract, we get x to the 0, or simply most people just cancel those out, so the x disappears. Now if you look at the next group, y over y cubed, this y of course is understood to have a 1 right there as an exponent. And if we subtract 1 minus 3, we get negative 2, or we simply leave y, there's 2 y's left on bottom. Because if I have y to the 1 over y cubed, that's literally y over y times y times y, isn't it? And you cancel that, you're left with just 1 on top with y squared, of course, on bottom. Okay? So that's another way to look at it. Or a simple rule of thumb, if you want to avoid negative exponents, subtract the 2 and put it where the higher exponent is. And the last one, z to the 4 over z squared, of course leaves me with 4 minus 2, would leave me with 2 z's on top, right? So it'd be z squared, z times z. And there's the complete answer. However, if you're asked for where it is, y cannot equal 0 in this case, if you're looking at defining where it exists. Alright, let's look at number 6. Now, as you can see, quite different. Number 6 doesn't have a multiplication in between. Look, it's a subtraction. So it's a binomial on top, right? It's more than one term on top. Alright, so we call that a binomial. So we have a binomial on top and a binomial on bottom. When you cancel binomials, you cancel a binomial with another binomial. You cannot cancel parts of a binomial or pieces. So there's no individual canceling you can do here. However, you should start to recognize what's called GCF, greatest common factor. In the numerator, the top part, no, nothing common, so I just write x minus 5. In the bottom part, however, you should see that there's a 2 common. GCF has a, right? So we factor 2, we leave it there though, you can't just throw it away, you leave it in front. And I'm left with 5 subtract x. And again, anytime you want to check a GCF, just multiply it back out. What is 2 times 5? That's 10. What's 2 times negative 2? Negative x, that's 2 negative 2x. So you can double check it fairly quick, right? Okay, so just watch for that. But that's fairly simple. Now, you'll notice you have x minus 5 on top and 5 minus x on bottom. Now, I'm sure in your class, now we've already demonstrated what we call negative 1 factoring, or factors that equal negative 1. And anytime you have the pattern a minus b over b minus a, that's always equal to negative 1. So it doesn't matter what it is. What I give you, it doesn't matter. Alright, so if it follows that pattern, then it's equal to negative 1. Here, let's do a couple more quick examples here. So if I had 4x minus 1, then the bottom is 1 minus 4x, then that's equal to negative 1. Okay, so obviously it only works with minus signs, and they are in opposite positions. One is a negative of the other. Okay. Alright, let's just do one more. Let me delete that one, and let's try, what to say if I had 3x minus 5, and the bottom would have to be 5 minus 3x in order for that to be negative 1. Okay? Alright, so based on that knowledge, so watch for that, then we have what's called negative 1 here in this particular problem, don't we? You can see x minus 5 on top, 5 minus x on bottom. Now the simplest way is just cancel them like you normally would and put negative 1 there. Okay, so therefore we're left with negative 1 over 2. Alright, so watch out for that. They're negatives of binomials that are negatives of each other. Now the next one is a binomial on top and a monomial, or a single term, on bottom. Now you can do this a couple of ways. You could separate this into two fractions. 2x squared over 7x plus 6x over 7x. That's one way. However, following the patterns we're doing today, okay, following that, I think the best way is we'll stay with the factoring. Okay, so what we're going to do is factor the top if possible, factor the bottom if need be or possible, and then cancel where we can. Okay, so let's look at the top and think of it as a binomial and what is common to that binomial. Alright, if you look at it, you see 2x is the GCF here. So again, factoring out 2x, I'm left with just x plus 3. And on bottom, I still have a monomial term, 7x. Alright, now what do I do in this situation? Well, I can't cancel any of the binomial because there's no other x plus 3 there, or 3 plus x. Remember, a binomial cancels with a binomial. So the only thing I can see canceling now are the x's right here. See them? So if I cancel both of those, I'm left with 2 outside of x plus 3 over 7. And that's all you can do in this case for simplifying that particular expression. Alright, have a look at 14. Now in number 14, I have a binomial on top, and now I have a trinomial on bottom. Okay, so this one's going to take a little bit longer. Now, again, when you see a binomial, you're looking for difference of two squares, right? Difference of two cubes, or sum of two cubes. However, always look for GCF first. And as you can see in this binomial, excuse me, I do have a common factor of 2x. So if I factor 2x out of the top, let's see what's left. Okay, so 4x divided by 2x leaves me with 2x, and 2x divided by itself or factored is 1. So, right, and again, anytime you're not sure if you factored a GCF right, just multiply it back out and see. In other words, use the distributive property and check it that way. Now the bottom is a trinomial. Now we've been teaching a method of decomposition. There's also guess and check method. There's many methods factoring a trinomial. I'm going to use what's called decomposition, or some people call it product sum. Now the product is always the leading coefficient times the constant. Okay, so the product I need is 2 times negative 3, which of course is negative 6. Alright, and the sum that I need is the middle term, which is 5. Now that means you've got to find two numbers whose product is negative 6 and whose sum is positive 5. Okay, so product of negative 6 and a sum of positive 5. Now, if you play with the numbers for a bit, you can come up with them. They are negative 1, of course, and positive 6. Right? No other two numbers will do. So negative 1 and positive 6. Now, how do we finish factoring that trinomial? Well, I'm going to move up here in the middle a bit and watch. So I have 2x squared plus 5x minus 3. Alright? Now, I found the two numbers, and that's what I split this in. I split that into 2x squared plus 6x minus 1x. It doesn't matter the order. I could have said it the other way. Okay, I could have said the order I have them down there below. I could have easily said, okay, minus 1x plus 6x. So again, I'm using these two numbers right here to make up positive 5x. So I'm splitting it up into those two. Minus 3. Okay? Now you have to factor by grouping. 2. What's common in this group and what's common in this group. Okay? So we just move to the right here a bit. Now you can see what's common in the first group, and the common in the first group of 2, this group right here, is of course just x. So if I factor x out, I'm left with 2x minus 1. What's common in the second group? Now the second group of 2, I see a common number of positive 3, and I'm left with 2x minus 1. So therefore, now I have a common binomial of 2x minus 1, and the other factor is x plus 3. Okay? So now it looks a little confusing there with all that written in, so I'll just take all that out. So the bottom factored 2. Alright, let's go over it again. Bottom factored 2. Alright, it was 2x minus 1. Oops, 2x minus 1. Let me fix that. Alright, 2x minus 1 and x plus 3. Now, look what cancels. Now you can see it, can't you? Right? We have the 2x minus 1 right here on top, canceling with the 2x minus 1 on bottom. Right? So cancel the whole binomial with the whole binomial, leaving you with just 2x on top and x plus 3 on bottom. And again, for further clarification, x cannot equal negative 3, because that will make the denominator 0. So you should write that at the end of each rational expression, but I don't think we're requiring it in this type of answer. So there's your answers to number 2, 6, 7, and 14. Okay, in practice 3 of book 2.